Okay, good morning again, everybody, and thanks again to Teresa and Marcello for inviting me. Really very nice and interesting workshop. Today, what I want to do is just sharing my personal thoughts on the topic of safety of machine learning. So I'm not going to give a technical talk, and I'm not going to trying to provide technical solutions or attempts to solution. But while my goal is most to raise issues and to share with you some issues on safety of machine learning. So let me start with this slide that can appear unrelated with respect to the talk, but it isn't. The Black Cloud, one of my favorite science fiction novels, maybe you have already read it. It's a science fiction book, and well, I should say hard science fiction, because was written by Fred Hoyle, who was a real scientist, a British astrophysicist, working a lot, especially on black holes. And well, this is a novel that I like a lot. It's a very old book, 1957. It's a intriguing story about the arrival from the outer space to the solar system of a huge cloud of gas that is going to approach the Earth and is blocking partially the sun radiation, so causing serious problem to the human life. And so the British government, in the first part of the novel, appoints a selected team of scientists to investigate this strange phenomenon, this huge cloud, and to understand if there is any chance to do something, any possible countermeasure to protect the human life. And so this group of scientists start to investigate this strange cloud, and after a lot of attempts, they understand that, well, the motion of this cloud is not following the physical laws. So it looks a motion with a purpose. And so one of the scientists, that is the main character of the novel, argues that, well, maybe this is not a physical phenomenon, but the cloud could be a living organism, maybe could be intelligence. And this is the real start of the story, because the scientist decides that they should try to communicate with the cloud, supposing that it's intelligent, and possibly to convince the cloud to change the route, because it's blocking mostly the sun radiation. And this is one of the intriguing part of the story, because they attempt in many ways to establish a communication link with the cloud, but they fail. They use very sophisticated technique using the best of the technology that they know, but they fail. And after a while, one of the scientists understands that they are failing because more or less they are using a human-centered paradigm for communication, that it doesn't work. It doesn't work because the cloud is a very different kind of intelligence. It's a fully distributed intelligence. And so it doesn't understand. And it's very funny, because when at the end they are able to establish the communication link, the first word that the black cloud say is, well, I'm very surprised that intelligence can exist in solid form. Okay, and so and so well, and so at the end they establish the communication link. And well, in the second part of the book, many things happen, but I say nothing about if you want to read the book. Well, so this brings me to the first issue that I want to raise without any clear solution, is about the anthropomorphism. Anthropomorphism in machine learning, and more in general in artificial intelligence, because my personal view is that we have some issues to consider about our human viewpoint in machine learning, human-centered viewpoint in machine learning. For instance, related to this question, I selected two questions, but there are many others. When we, well, for instance, in robotics, we like to fabricate robots with human appearance, humanoid robots. Is this good? Or, well, because sometimes it looks that we raise great expectation about what robots can do because they have a human appearance, but sometimes these expectations are not met, are not satisfied. And the other, more close to machine learning algorithm for decision making, sometimes we are very disappointed because machine learning algorithms, they make stupid errors, of course, from the viewpoint, our viewpoints. Should really we be disappointed or not? Or we are using an anthropomorphic viewpoint. Consider this. This is a clear example of what I'm telling. Is a humanoid robot. It's called HUML16. Well, I would say that is considered, and it is, the best product of Italian robotics. It's fully made in Italy, so we are proud of it. And has been fabricated, fully made at the Italian Institute of Technology. It's a quite sophisticated robot because, well, it's been fabricated over, let's say, 10 years. At the beginning was a prototype of an European project called BabyBot. And you see, it looks a baby. It can move arms, head, and it can walk slowly, but it can walk. But now I want to focus on the vision capabilities of HUML16, and in particular on the object recognition capability, because it's the main visual capability that this robot has. It's able to recognize, well, a quite large set of objects. You see examples here are, well, let's say, common use objects. You see, well, plate, cup, soap. Well, this is just a few examples. By the way, well, this data set is available, publicly available. You can download it from the website of HUML, of the Italian Institute of Technology. Let me focus on this object recognition capability of this humanoid robot. This is the pipeline. This is the object recognition pipeline. First thing, well, the designers of this robot, they decided to use, let's say, the best of machine learning today, so the main paradigm, and so deep learning. So, well, the inputs of the video camera for the robot are just the pixel, the image pixel. So it starts with image pixels, and then they use quite complicated deep convolutional neural network to extract some features from the pixel, from the raw visual data, from the image. And so they extract a set of deep features computed using the convolutional neural network. Then they use a very simple classifier, a linear classifier. It's a linear support vector machine, more or less. And finally, well, so HUML is able to make a decision about the object that you are showing it to the robot. Well, it's quite nice because you can show the robot one object, he tries to recognize. When he is able to recognize, he tells the name of the object. Otherwise, he asks which object it is, and it's able to do some incremental learning. So it's quite interesting. The performance, the accuracy for object recognition assessed, let's say, in vitro, are very good. Really very good, close to 100%. Especially the results that you find in the papers are extremely good. But also when it's working in vivo, and so while the instructor shows objects to the robot, well, the accuracy is quite good. So, well, you can suppose that it's quite robust. So, well, but the question is, it's really so robust? I mean, if I show him an image that is slightly modified, just I modify some pixel, I can imagine that the accuracy is good. Well, in my laboratory, over the last 10 months, we did some experiments, also exploiting prior works from the literature. I will give the credits, of course. It's not totally one new things. And we have seen that, well, HICAB, the object recognition capability of HICAB is not so robust. Well, I mean, it's not so robust how we could imagine if we use a human-centered viewpoint. Because it's enough that you change really a little bit some pixels of the image, and one plate is recognized as a cup. Of course, you cannot modify the pixel values at random, but you have to use this optimization algorithm to identify which are the changes of the pixel values that completely changes the classification of the object, the recognition of the object. But it's possible. It's not difficult, because this optimization problem, I don't go into the detail, is something that we are able to do. It's quite simple. So you take this image, and solving this optimization problem, you find which are the pixels that you have to modify. But the interesting thing is that if I add these slight variations, slight noise, to the original image, for us humans, the image is exactly the same. You cannot distinguish. But for HICAB, it's completely a different object. Well, it's not only a problem of HICAB, of this humanoid robot. It's not a unique case, this strange situation. So, well, if we consider in other settings the performance of deep neural networks against this kind of, let's say, adversarial images, we find that there are other interesting situations. Well, 2 years ago, has been published at NIPS, a major machine learning conference, a paper entitled Intriguing Properties of Neural Networks, showing that if you consider ImageNet, that is the most popular and large image database for object recognition in the machine learning community, and you use for recognition, for recognizing the objects in ImageNet database, a deep neural network, again, it's quite easy to fool the network. And if you had some noise, not random, but using a particular algorithm to generate adversarial noise, you can generate this image that for us humans, well, it's exactly the same. But for the deep neural network, and not only one, for many different neural networks, many different architecture, different parameters. So it's not just one case by chance. This is an ostrich. And there are many others funny and interesting examples of this kind. Well, last October, at a computer security conference, some researchers, they show that they invented a systematic method to generate, some changes in the face images of people, and they are able to fabricate this kind of eyeglasses, so that if the face recognition system uses a deep neural network for recognition, that is something that also Facebook does, okay? This gentleman with these eyeglasses is recognized by the face recognition system using deep nets as this lady. Okay, so it's quite impressive, and they really fabricated these eyeglasses. So it's quite interesting and funny. And of course, things becomes more serious if you consider the use of deep neural network for Yes, please.
Just a comment.
Yeah, sure.
In 2011, I think there was a paper when they did something similar, but back then it wasn't neural network. It was a pipeline of hug feature.
Yeah.
Combined with LGM and special pyramid, and they got pretty much the same result. So
Sure.
this adversarial
Definitely.
Fooling is not limited to neural networks.
I can confirm you that while we did many experiments with other recognition technologies, you can fool with similar adversarial images, support vector machine, and many others. Yeah, I will say something, just something about that. It's a technical detail, but yes, the answer is yes. The answer is yes. Of course, if you imagine that you use deep neural networks for mission-critical application, for instance, on board of self-driving vehicles, this can become quite worrying. And indeed, again, a recent paper on IEEE Security and Privacy journal reported some result, again, a result in vitro. So they didn't put on board of a Google car the system. Yeah, it's just experiment in vitro, but they reported.
There is an experiment in the real world, and the first person to die in a self-driving car. That was exactly the effect.
Yeah. What was a Tesla car? Was a Tesla car? Yeah, with Tesla car. Even if, well, the reports that I read, I'm not sure what happened. But yeah, maybe.
One story that says it was such a.
Yeah, the story is similar. I agree. And well, in this paper, there are some results that show that the deep neural network misleads a stop sign with a yield sign. Yeah. Of course, suppose that you take the image of this stop sign, you manipulate the image with an algorithm that is able to change only a few pixels, but in a way that for the deep neural networks, the classification changes a lot. I don't want to be too technical. This means that while the deep neural network is very unstable, very small variation of the inputs can causes large variation of the classifications of the final recognition. And this is still an open issue. I will say something about my personal opinion and what I'm doing to explain this issue. Well, there are some recent articles also on newspaper or not computer science journal. There is a nice article a few months ago on Nature, and also articles on newspaper which express a big disappointment because this is the best of machine learning, deep learning. Some products are going to the market. Probably they will be used for mission-critical application. And, well, they look so brittle. Just a little variation of the inputs and the decision changes completely. So, well, my question is, should we so disappointed? It's so strange that, because, well, also in computer science and machine learning, there are some paper which raises serious concern because they say, well, it's impossible to explain. What is happening that it's so unstable? Well, my personal view is that, yes, it's a problem, it's an issue, but there is nothing completely new under the sun. This is a problem that you can explain going back to the fundamental of statistical decision theory, and is that imagine that, this is of course a very simplified view. Imagine that you have a two-dimensional feature space, so it means that you have only two deep features to characterize your patterns, your samples. And now I'm considering just two classes. That is quite common in security application, the bad class and the good class. And imagine that this is the decision boundary that the deep neural networks learned to discriminate between the two classes. When I change my images, of course using a particular algorithm to select the pixel that in an adversarial way, what maybe happens, this is the hypothesis that I'm testing with my colleagues in my laboratory, is that, well, probably you generate new samples, adversarial images, as I have shown you, that falls in very low probability regions in your feature space. And of course, from a Bayesian perspective, well, it doesn't matter what happens in very low probability regions. And so the decision sometimes is completely different. It's just my hypothesis. My hypothesis is something that I'm trying to test. Of course, well, this is something that is well known in Bayesian decision theory. Zero probability, you don't have to take care of that. Events with zero probability. Of course, there is a potential solution, and we wrote something with my colleagues about that, and it looks to work. On an intuitive basis, could be enough if you force deep neural network to learn a closed decision boundary. Because if the decision boundary is closed, of course, it's much more difficult to have adversarial samples that fall in low probability regions and they are misclassified. So what we are doing is to modify the learning algorithm of deep neural network so that the neural network learn a decision boundary which are closed. And this should improve the robustness, in my opinion. Of course, there is a price. There is a cost to pay that if you use closed decision boundary, probably when you have no malicious situation, the error rate increases. There is a price to pay if you want to protect your learning system. Okay, this brings me to the second issue. It's an open issue. Has been raised by this young gentleman 10 years ago, and well, to my opinion, is still open. Can be machine learning safe? Well, now, since 2006, well, this gentleman simply raised the question without providing any solution. But was a nice question. And it's still open. Even if, well, a lot of research has been done. Now we know things much better. But the question is still open. Now let me move to another practical case that, in my opinion, raises another interesting question. Android operating system. It's very, very popular. Well, 1 billion of users of Android mobile operating system. Of course, Android operating system is very popular, and so we have a lot of malicious applications. If you have an Android operating system, you should be careful when you download a new app, because it could be malicious and not a genuine legal application. And the problem is so serious that there are a lot of countermeasures. I mean, a lot of malware detectors for Android operation system, especially mobile. And well, I don't use Android operation system, but if you use it, I recommend you to use also a malware detector. One of the most famous detector and most recent is this one. Dribine has been designed by a group of computer scientists, German computer scientists. Works well. I and my laboratory, we cooperated with the inventors of this malware detector. Is very simple. In the essence, is a linear classifier. And already this is interesting. They selected a linear classifier because they claim, you see the title of the paper, that it's linear, so you can understand the operation. It's questionable, but this is the situation. For sure, from an engineering viewpoint, it's very fast because it's linear. Yeah, so it's quite fast. Well, from the technical viewpoint, they extract some feature from the code of the application. The detail or the technical detail are quite complicated. I skip them. And then they use this feature with weights each feature has a weight related to the importance of the feature. The weights are learned with one of the algorithms that you can use for linear classifier, and then you make the decision. What is the point? What we discovered collaborating with these people who invented Dribine, that is quite easy to evade this detector, because usually they prefer to have very sparse weights, very sparse. Why? For computational reasons, it's more fast. But of course, for an attacker, it's much more easy to change the value only of some feature. How they do? Well, they use a lot of tricks to obfuscate the code of the application, are well known. And so it's quite simple to evade the detector. And so what we did with inventors of this detector, we proposed a new version of detector which uses a different learning algorithm that doesn't promote the sparsity of the feature weights, but prefer uniform weights values, and really it's much more robust. But from the conceptual viewpoint, and this is the issue that I want to raise, this is quite interesting, because it seems that in machine learning we have a problem with a trade-off between sparsity and security. If you want to have a linear classifier very sparse, that is fast and probably is more easy to understand, well, it could be a problem if you are under attack. And more in general, and this is the third issue that I want to raise, suppose that the sparsity can facilitate interpretability. This is in some sense an open question, but probably another question is that there is a trade-off between interpretability and security in machine learning. Well, of course, this is a specific case. We are speaking of linear classifier, so it's not a general. But this is another issue that I consider quite interesting if interpretability comes at a price. Last issue, and I go to conclude. So, as I told before, when, people look quite disappointed and worried, especially potential stakeholders of machine learning technologies, of deep learning technologies, for these errors that looks, quite stupid for humans. The question is, what should we trust? We should trust in algorithms as well as we trust in humans or not, because, deep neural networks seems to, they recognize this like this. That is quite disappointing. I think that to think about this issue, I don't have any clear answer. We should come back to, a lot of investigation that has been done in behavioral economics. There is a long tradition in behavioral economics. So again, nothing new, completely new under the sun. In behavioral economics, there is a lot of papers about how much humans are biased, how much decision-making algorithm is biased, and especially, that is to me the most interesting question. When should you trust in humans, and when you should trust in algorithms? Because this is the point. We cannot imagine that we invent algorithms that are much better of humans, especially nowadays. Okay, so this is an interesting question, because we know that of course there are biases of machine learning algorithms, but we know a lot of cognitive biases of humans, decision maker. We've spoken about that with the last speaker. And they are we should be disappointed when we imagine that the judge could have a cognitive bias or in legal interpretation. And there are a lot. And so my last slide is my personal impression that to think about this issue, we should back to the future. Because in the 80s, when I was doing research in machine learning, there was a strong emphasis about the dichotomy between symbolic and sub-symbolic processing. A lot of paper about how to integrate neural and symbolic method and so on. Then for 10 and 50 years, nothing more. Just statistical learning theory. Now again, this year, a new workshop at NIPS just focused on how to integrate neural and symbolic approach. So it's really back to the future, to me, and this is my impression. And okay, thanks for listening.
Thanks, Roli. We have 5 minutes for questions, so just okay for 5 questions. Okay, so Bettina.
Thanks a lot, that was great. I recently heard a talk that I think illustrates or could be something that you should attack next, unless you've already done that. So Cynthia Rudin at FatML presented work together with Jamin Singh and Berg Uskun, I'm probably mispronouncing that, call it interpretable classification models for recidivism prediction. So what she argues is there is this whole fuss now about predictive policing and how intransparent these models are that supposedly tell you whether someone's at risk of committing a crime. And she says there's been score models in police work since at least the 1920s. And then they go and say, here we have a mathematical optimization approach that gives us very simple scores, and it's totally provable that this is perfect and the best and so on. And given what you told just now, this makes me even more worried. So please look at that work and say something about that.
Okay. Oh yeah.
I think it's really important because
definitely.
So many.
Yeah, predictive policing is well, it's very serious, of course. Yeah. So yes. Yes, well, to be honest, I'm not familiar with it.
Yeah, but it's exactly that point of we need the interpretable models, and isn't it nice that we can interpret this model and then there's optimization going on in everybody's interest. So we need to drill holes into that.
Yeah, the problem is that probably the next speaker will say something about that. What is interpretability? Or which kind of interpretability we want?
Yeah.
Okay, so
maybe I'll just pass on this because I've been asking questions.
Okay.
So one question, a technical question. So you've shown that to take an image, you manipulate a few pixels, and the algorithm gets it totally wrong. So my question is this an academic problem or a real-world problem, in the sense that do we encounter those kinds of manipulations in the real world, or are you just taking the image out of like a natural image domain?
Great question. Of course, is my main is one of the focus of my actual research. The answer is well, we have already a paper. I didn't mention it that showed that when you collect this adversarial image using a real video camera, you obtain the same effect. So it's an attack that can happen. Well, of course, I'm speaking of collecting adversarial images with a smartphone. It's completely another story and should be tested in vivo if I'm using a video camera on board of a car. So most of these results are still in vivo. But I don't think that are an academic, an academic exercise. And for sure, well, we are already able to prove that I can create, and well, you remember the gentleman with the eyeglasses? These are real eyeglasses, and they collected the images using a real video camera. So it's not an academic exercise. It's something that, well, of course, when we speak of security, one thing is that an attack is possible, and another is how much effort you need, and if it's worthwhile. It depends on how money you can get. Okay, and so this is another story.
Okay, and Catherine, okay.
So I think that I totally agree with your point that the question is when to use what kind of method, because it seems to me that whether we care that some attack on machine learning leads to the wrong classification depends completely on, first of all, how likely is this to happen, and what's the consequence.
Exactly.
And so I also just had a clarification question, which is that when you were talking about low probability examples, what you mean by low probability, I'm assuming, is that there aren't very many of them in the training set, right? Is that what that means?
No. it's a little bit technical. It's a little bit technical. Well, I'm not telling that the object, the real objects for which you are collecting a picture are rare objects. But then, when you use a deep neural networks, it takes the image of the real object and it transforms it in a feature vector representation. And the feature space is so complicated with so many dimensions that sometimes the mapping of the real objects is into a region of the feature space that is a very low probability region. Okay? Well, what happens, it's a little bit technical, is that the decision boundary of the deep neural networks, most of the samples are very close to the decision boundary. And so a slight change is enough to change the decision. Sorry, it's a little bit technical, but this is what, so it's a problem of stability of the learning algorithm. They are not stable.
So
this is the problem.
Does that necessarily mean that these are low probability events in the real world?
No, definitely not.
Okay, so that's Amy.
I'd add that. Well, so in the case of the glasses, like this clearly can happen in the real world, but in the case of when you sort of optimize a pixelized adversarial example, then you might actually produce an image that truly would be impossible in the real world. It's like you create this sort of artifact that never would come out of a real timeline. So you could sometimes create something that even in the natural space, to a human it's indistinguishable, but in the feature space might actually be something that truly would be almost impossible for a natural image. Like it only comes about because you're trying to pull it.
Yeah, but it's exactly the vulnerability that you can exploit. Yeah. Okay. It's like also for humans we have cognitive illusions. And I could exploit them, to attack you.
I think maybe that raises the point that sometimes what we care about is do we make the same errors as the machine? Like when we think about do we trust the machine, it's if we would make the error anyway, then we don't lose anything by turning over control. But if we get similar accuracy to the machine, but it has a completely disjoint set of weaknesses, then
I agree.
We have to think about these vulnerabilities.
Yeah, but I believe, I repeat, well, the issue that I find interesting is when you can trust more machine and when you can trust more humans. This is something, it's not new. In behavioral economics is one of the main topics.
I was wondering, because in image recognition you basically have like 500,000 of so you have a 500,000 dimensional space. And basically, all the images that kind of make sense, they are distributed in a very tiny region of this space.
True.
So, and you're basically optimizing just this space, and if you have an image that doesn't make sense, you basically have no guarantee that it does something right. I was wondering if you go to some completely other domain, like maybe natural language processing, when you use LSTM, which uses even more dimensions. Is the same problem even here?
Well, to be honest, I don't know. Well, for sure, high dimensionality is one of the problems, but it's not the only problem. I think that is, again, technically speaking, is the kind of decision boundary that deep neural networks find. It's the kind of decision boundary. And indeed, while you can show that is the kind of decision boundary, they have many, let's say, blind spots. And the other is the most of patterns, as you said, are very close to the boundary. And this is a problem, because a little change, and you change the classification.
And just another small question. When you make this trade-off between sparsity and security, the second part of the presentation, basically it's looking at the cost function is just added regularization and
Well, yes. In other papers, we have shown that it's really a problem of regularization, and you should consider the kind of noise. Because there is a link between the manipulation of the images and the noise, and so you can select the proper regularizer to protect your classifier against that kind of attack. It's a matter, again, nothing new. Well, in a paper, we exploited many old results of robust optimization. In robust optimization, they already addressed a similar thing. Yeah.
So, thanks.
Thanks.